Hello. In the last video, we were working on this scratch project and we got a rocket that can shoot out of our spaceship in the different directions. And in this video, we're going to move on to the asteroid or rock. So we'll just get started on that. I did figure out my projects and the project names. So to start off here, we'll save as copy. So this will become a copy, and then I'll just edit the name to part 3 later. So there may be a little discrepancy in part 1 because I didn't realize you have to save as a copy before you start working or it's going to auto save. So some changes got auto saved to part 1 and then I took them out. It's sort of. So I took the rocket things out, but there might be a small discrepancy in the part 1 project folder file, or shared project, I guess you would call it. So yeah, we'll just go on with the rocks and see what we can do with that. So with the rocks, we don't want to spend too much time on the artwork, so we're not going to. And that is just kind of going to be left up to people how much work they want to do on the artwork. So I'll just start off with an outline, a gradient. We're just going to be working in some different grays here. So we'll make a darker inside, a lighter outside. And then a little bit brighter to the outside. So that should just give it a little bit of pop on the screen. We'll start off with the circle. We have the ship is still at a size scale of 30%. We'll name this as rock. So that's fine. And we'll just size the rock without scale sizing it, so without the scaling. And we won't do a lot of work here, so I'm not going to aim to build the most beautiful boulders we've ever seen. Space boulders, or whatever we want to call them. And we'll just do just enough editing to get something that's kind of passable as our space rock. But we don't want to spend a lot of time on it. Like, these are things for people to do, and the artwork is something for people to work out for themselves, really. So we'll just do a little bit, sort of get something that's somewhat passable kind of deal. Just make something passable. A little bit of a random rock-like shape. And I'm just looking at the size of it and watching for any peculiarities. Sometimes if our handles are overlapping, it can cause strange stretching and sharp edges that look pretty unusual. Sort of like that. So something along those lines. I'll just check this handle here. It's probably a little funny, and it looks like there's something a little funny here. So we'll avoid doing a massive amount to this and just get something. So I'm not hugely artistic to begin with, so maybe that's getting a little bit small now. Let's get it a little bigger. Maybe something along those lines would work. Or maybe just get that a little bit out. So that should be okay. Let's call this rock 1. We'll make rock 1, 2, and 3. So what we want here is we'll just duplicate it. We'll change it a little bit. That was not what I was looking for. That will kind of mess up both of these control points. So what we'll aim to do now is just shrink this in a bit. And change its shape enough that it looks like a different rock. So maybe something along this line will be fine. So let's see what our size difference is there. The shape is good enough. So we'll just get it to a size that looks about appropriate. So what I'm thinking is the big rock will break into 3 smaller rocks. So it should be around a third the size kind of deal. So let's see, big rock. That one's getting a little too small, I think. So somewhere around there. And yeah, this is really just open for people to experiment and play around with. So we'll go back to the handles again. Let's just take this one right out of there. We'll put in a new one. Just shrink this in. Let's get that one out and we'll put in a new one. And we'll take that one out and put in a new one. And let's see what our size difference is there. The shape is good enough. We'll just scale it down. We want this one maybe about that big. And these are open to experimenting. So we have large, second stage, medium. We'll bring that down just a smidge. And then the small rock, and maybe that can come down in size a little bit too. Just center these as we go. Now this large rock, we're going to duplicate it. Let's bring it down to the bottom. We're going to call it just big. So that'll be its name. And what we're going to do with this is we're going to draw a big circle. So the purpose of the big circle is to make it so that this rock is able to go completely off of the edge. Now, I didn't do that right. Let's undo that, and let's hold down the shift key to make a circle. And then let's move this back so we can see the asteroid on top. So the asteroid by itself can't go right off the edge, but with the large circle, it's now able to go off of the edge. This will also be used as a measuring tool later. So for now, we'll just go back to this rock, and we're pretty much ready to start in the code. So in here, well, actually it doesn't matter. We can start in rock for the code. So we'll need variables. We'll make the first variable is, we'll make it available for all sprites, because this is just for a count on how many rocks there are. So we'll start with a count of how many rocks there are. In events, we'll go when the green flag is clicked, set rocks to 0. So there'll be 0 rocks. This one will start off hidden, so it never will really exist as anything other than clones. So because we want it started off hidden, we're going to start it off hidden. And we'll also set the size scale to 100% to make sure that we've started our scale at what we want it at. So we don't want to make assumptions. So that's what happens when we start off. Now let's see, what else do we need for variables? We're going to need a speed. We're going to need a direction. Now, rocks are going to turn. So in motion, we have a variable already called direction, but that's what's called a local direction. So we're using the local direction of the ship. So when we turn it, it thrusts in its local direction. For the rock, we want a global direction so it's able to rotate, but have a global direction rather than follow its local direction, which it wouldn't be able to travel properly if it was following its what's called its local direction. It would do what the ship does. So as it's rotating, it would fly in circles like this. So we don't want that, so we want to create a variable for this sprite only. That will be its global direction, because its local direction is not useful to us. So we have to create a variable for direction. We'll need a variable for rotation, because that will be a random number. So let's see, we have speed, rotation, global direction. So that should get us all the things that we need. We're not going to show them on the screen, but we'll leave rocks on the screen, because when we start destroying rocks, we want to be able to have a count of them. So we have clicked. The next event we'd be looking for is when I receive this start signal. So when it receives the start signal, what it's going to do is create 3 clones of itself. So we're going to go create clone of myself 3 times. And then when I start as a clone. So then it's what it's going to do when it starts as a clone. So it's at this point we want to start determining things like its direction, its rotation, and its speed. So we'll duplicate these. We want to do global direction. We want to do its rotation. And we want to do its speed. So these will involve picking randoms. For its speed, we'll pick a random between 1 and 2. So that's not a lot of variance. This should also likely, when we have different levels, so as we advance through levels, the speed of the rock would likely increase. So this number would more likely be a variable that is related to level to multiply by to make the speed of the rocks increase slightly per level to increase the difficulty level. So you would have the speed of the rocks able to increase to a larger speed, as well as having more rocks appear. But for now, we're only dealing with getting a first level and getting the math for a first level working. So for global direction and rotation, these are not this simple. So for rotation, we're going to need a repeat until. So we want to get it to be able to rotate in either direction, being picked randomly. So in order to do that, we're going to need to be able to measure it. So we're going to go ABS, of rotation is greater than 0. So we want to make sure that our random number is not equal to 0. So we're going to repeat until the ABS of rotation is greater than 0. So an ABS means if the rotation calculates as a -5, an ABS of -5 will be 5, which is greater than 0. So ABS is just a way to strip away a negative from a negative and positive number, just for the sake of measuring it only one time to make sure it doesn't equal 0. So we will set the rotation inside of this block. So we'll just change the order of this. We'll need to do something with global direction, is also not this simple. So we'll be picking a random between -5, which will let it rotate in one direction backwards, and +5. So that gives it a bunch of speeds, but it will never equal 0. It will keep doing this until it gets either a minus number or a positive number, but it will never settle for a 0. So it will always have a rotation. Okay, so let's see, global direction. Now, when we're doing a direction, let's make the rock visible again so we can look at it as an example. When a rock gets destroyed and it's up against the edge, it has the potential to become a smaller rock that's hidden behind the edge. So when it's hidden behind the edge, we do not want it to have the possibility of traveling either 180 degrees or 0 degrees. And then likewise, we don't want it to have the ability to travel along 90 degrees or -90 degrees. We always want it to have an angle that is not equal to one of these angles, so it can always be straying back onto the screen and can't get stuck off of the screen where we can't see it. So we want to eliminate that as a possibility. So that would happen when we set the global direction. So what we would want to do is, first off, we'll take and we'll set the global direction to a random number. So we'll pick a random number, except we'll exclude 0 degrees. So we'll pick at random at 10 degrees, and we'll exclude 90 degrees by picking between 10 and 80. So now it is always going to be 10 degrees off of 0 and 90. From there, all we have to do is set the global direction. And we're going to do this in 2 lines. It can happen in 1 block of code, but we'll use 2 blocks to do this so that it's not this great big long line. We'll pick a random number between 1 and 4. We'll multiply it by the rotation. So we'll pick a random number between 1 and 4 to multiply by the rotation, that's between 10 to 80. So if we go up and we look at this using the point in direction, that will give us the full 360 degrees. So it will randomly pick inside of this field with 10 degrees excluded. So if we exclude 10 degrees, yeah, this won't let us exclude 10 degrees in the math here by its own clicking, because it always moves by 15. So it's going to exclude 10 degrees from either side, and then multiply it by a random number between 1 and 4. So 1 times, 2 times, 3 times, and 4 times. In each of the 4 quadrants, it's always going to exclude that 10 degrees. So no matter what, it will have to be traveling, whether it's going in this direction, or this direction, or this direction, or this direction. It will not be traveling on a rotation degrees that will allow it to be hidden behind an edge. So hopefully that explanation is clear. It works, and hopefully the explanation for why it works is clear. Okay, so we have our direction, our speed, our rotation. The last thing we need is for it to appear at random positions. So we're creating 3 clones. We want them to appear at random positions. So we can go with go to random position. Now, this leaves a problem, and we're going to leave that problem in existence. And the problem with it is this can be the random position. So its random position can right now instantly mean death for the ship. Now, we could build a series of checks here. Well, maybe we'll do that. And we'll just see how far we can get in a reasonable amount of time and relieve this problem. This problem exists in my current project. So I've never actually relieved this problem, but let's look at how we would go about relieving it. We would go if, we'll need 2 of these. Up in motion, we have X and Y position. So we can just go if X position. We'll want the operator for absolute. So if the absolute of the X position is less than, let's get an idea here. So let's say we want that to be the safe zone. So that's 60 minus 60 in any direction. So if it's less than 60, if the ABS position is less than 60, take the position, the ABS position, and the position. We'll divide the position by the ABS position. So let's say we have minus 60. We're within minus 50. So we take minus 50 and we divide it by the ABS of 50. What it renders is a minus 1. So if we take that and we multiply that by our safe zone number, so our safe zone number is 60. So we have a minus 50 divided by 50 renders a minus 1 times by 60 will change the minus 50 into within the safe zone number. So I believe that this should create a safe zone. And then what we would do is go set X to this position. So that should be an X safe zone. Now we can duplicate this. change this. Oh, it's not letting me change that way. So we're going to need to get the Y position. On most variables, you can click them to change them, but apparently on this one you can't. So these we can just toss right off here. Then we'll duplicate and replace this with Y position. So I think that this should, added with the random position, should queue up all of our asteroids in a way that they should never land within the radius of the ship. So let's re-hide our initial one, and we'll just start, and what are we missing here? We haven't told it to show. So at this point we should have everything set. So now that they're into a position, we can show. So we'll just do this a bunch of times and we'll see if it ever lands onto the ship. So it looks to me like it's refusing to land on the ship. It's coming pretty close. So the 60 might not be a good enough safe zone. But that seems to reasonably give us a safe zone. So I don't know if we can find the position of this. Yeah, it's not telling me the position here, but it looks to me like it's landing in that safe zone area. So probably the way I could discover is to do this. So that would give me an idea where it is. So yeah, that looks like it was probably kicked out from being too close. So it was probably too close and got kicked out, because that looks like it's sitting right along a 60, I should say. So that gets us a safe zone. Let's hide that. We'll stop. That will make everything disappear. So let me just check on the time here. This is getting a little bit lengthy. We're at a half an hour, and so far we've managed to make the rock and get them to appear randomly. So I guess we'll press forward. We'll make a function block called move. We'll run without screen refresh. And yeah, it's worth noting that a lot of what we've done here should probably be in its own function block that runs without screen refresh, because nothing that happens requires a screen refresh. So this is the first point that anything happens on the screen. So we have move, and a lot of this stuff we could probably be making happen faster. So if we made a block called init, that's a standard short word for initialize. So we'll initialize the rock. So we'll call that initialize rock. We'll go run without screen refresh. We'll take this entire block, plop it in here, and now we initialize the rock, we move. So this is a lot more what proper scripting should look like. Is we make a function call to initialize the rock. That will happen more quickly now. Now we want to make the rock move. So making the rock move. Let's see. We have motion. We need change X, change Y, and turn. So these are the things that it needs to do to move. We need operators. We need multiplied by. We need the math operator here for sine and cosine. So that does our math movement. Because we have to move along our global direction while it's rotating in its local direction. So we need its global direction and speed. So we've set global direction, we've set speed, and we've set rotation. So what it will rotate by is its rotation. And how it will move is by speed times sine or cosine of direction. And yeah, hopefully the global direction is making sense. We'll make it make sense. So this should actually get us moving and rotating. And then we'll call this video at an end, and in the next video we'll come back and we'll deal with rocks getting stuck on edges, because they'll only be able to move up to an edge and get stuck. So we'll deal with that in the next video. So let's see what happens now. Nothing is happening. Why is nothing happening? Probably because move is only happening one time. So we have to remember all games occur inside of a forever loop. So we initialize and then we move forever. So we initialize and we move forever. Now let's try that again. We seem to have a directional issue. So let's see what the direction issue is, because it's only going in one direction. So there's obviously some kind of a math problem here. Let's, first off, we'll just check my math. Speed, direction, that's right. Okay, so let's look here. Speed, direction, cosine, x is sine, y is cosine. Oh, here's our problem. We're multiplying by rotation, and that's wrong. We're multiplying global direction by we're multiplying that by a 0 or something like that, so it's constantly getting a 0 direction. So we'll go down to variables, and this time we'll put the right variable into our math formula. So now we have the right variable in the math formula, and things should move in all sorts of different directions, and they'll just get stuck on edges. We can see them stuck on edges as they hit the edges. So we'll just experiment a bit. Things look good. That seemed to start right on top of the ship. So let's actually examine our safe zone idea here. Let's maybe change that to 70. And maybe the safe zone would also be something subject to levels. So let's try it like that. Should be more clear if we're outside of safe zone all the time. So that's all seeming pretty good. And yeah, maybe the safe zone is something that people messing around with this want to consider as a potential place to introduce difficulty level for higher levels of gameplay. So that's it for this video. In the next video, we'll come back and we'll deal with screen wrapping so that the rocks can come off and on to the screen. And we'll get the rocket and the rock interacting with each other, and we'll start looking at some of the difficulties for that. And again, I would mention that a lot of my ideas here are coming from watching the Griff Patch video where he does a shooter game similar to this with big lemons. Now I've changed the way that project works a little bit, but his content is very worth watching to get some ideas to go along with the ideas that I have, and might help a person to be able to change what I'm doing here into something that works for their project just as well as just copying mine. Just copying mine, there's not a lot of use in even following the videos if that's what a person's going to end up doing in the end, because the purpose isn't just to copy what I'm doing, it's to get an idea of why and then apply ideas that are better than mine, because it shouldn't be hard to come up with ideas that are better than mine. So that's it for this video, and in the next video we'll do screen wrapping and get some things getting shot. So we'll get shooting functioning so we can actually shoot the rocks. And until then, I hope this was helpful, and take care.